Welcome to the Cosmic Curiosity Garden, where we unravel the mysteries of our universe and existence. In this journey, we will travel into the bizarre, beautiful, and to most humans, an unsettling world of quantum fields. The invisible wavy fabric-like entities science says form the true foundation of everything we know so far. But are these fields real? Or are they just clever mathematical ghosts? In this journey, we'll explore the concept of quantum field theory, QFT, and why it has become the reigning model of modern physics. From the Higgs field, which gives particles mass, to the electromagnetic field, which shapes the visible world, we're told that fields, not particles, are what reality is truly made of. But how do we know these fields exist? What is the evidence? And could it all be an illusion created by our equations? This journey is designed to captivate curious minds and challenge everything you thought you knew about fundamental forces, particles, atoms, mass, energy, matter, and space-time itself. We'll answer questions like, what are quantum fields and how do they work? Are particles even real? What is the Higgs field, the electron field, the electromagnetic field? Do fields actually exist? And can these fields be observed or proven to exist? Why quantum field theory replaced the classical view of particles? The strange philosophical implications of field-based reality. What this means for you and everything you see, feel, and believe. Let's start with part 1. The creator of the universe created reality that hums with something we cannot see. We are not talking about atoms or fundamental particles, but something deeper, something stranger. All across the vast silence of space and the tangled geometry of the quantum world, an invisible structure vibrates. Not with sound, but with possibility. Every beam of light, every flicker of gravity, every breath you've ever taken has passed through it, yet no one has ever seen it. And if it were to vanish, even for a moment, so would everything else. This is not science fiction. This is what physics now believes lies beneath everything we think is real. We've long believed the universe is made of things, solid objects, tiny particles, tangible matter. We imagine the world as a machine built from gears too small to see. But as science carved deeper into nature's code, that illusion crumbled. What we found instead was a strange, ghost-like sea. To those who have studied particle physics, this ghost-like sea is called fields. Vast, continuous, omnipresent fields. Not just around us, but within us. We don't live on top of them. We live inside them. Fields are not like matter. They have no edges, no shape, no boundary. They ripple, vibrate, and sometimes create particles. Everything, electrons, photons, quarks, isn't a thing in itself, but a tiny storm in an invisible ocean. Every particle type has its own quantum field permeating all of space. Electrons are excitations or ripples in the electron field, just as photons are excitations in the electromagnetic field. Quantum physics tells us these fields are more fundamental than the particles we see. They are the canvas and the particles are just the paint. But here's the mystery and the catch. We have never observed a field directly. We see only the aftershocks, the particle, the energy, the flicker on an instrument detector screen. The field itself remains unseen, untouchable. And yet, it may be the only thing that's actually real. So what are these fields? How do we know they exist? Can something we've never seen, never touched, never truly measured, be more real than everything else? This is the story of what holds the universe together. The unseen architecture behind every atom, every force, every law of nature. This is the mystery buried inside the silence between things. So, are fields even real? You wake up in a world that feels solid. Your feet touch the floor. You grip a mug of coffee. You hear the sound of birds outside a window that keeps the cold at bay. Everything around you seems built from things, real things, tangible, firm, measurable, tables, trees, skin, bone. You know what's real because you can hold it, throw it, break it. But this sense of certainty, this visceral belief in solidness, isn't just incomplete. It's a lie that is so old, so embedded in the story of being human, that we rarely question it, until modern physics did. Let's rewind to the world before that unraveling, a world of clarity and contact. In the Newtonian picture of reality, the universe was made of tiny, indestructible particles, atoms, moving through absolute space, governed by simple laws. Every object, from a marble to a planet, could be described by its position and momentum. This mechanical vision of the universe became our default. Everything made sense. Everything was local, predictable, real. Touch was a transfer of forces between surfaces. Color was a property of reflected light. Heat was the agitation of microscopic atoms. And every one of those atoms, we believed, was a hard little billiard ball, spinning through space like celestial marbles, a grain of sand, billions of atoms, a human, billions of atoms. The logic was comforting. The simplicity was seductive. But it was also wrong. Because then came the cracks. Light, it turned out, didn't behave like a stream of particles. It diffracted, interfered, bent around corners. And in an amazing series of discoveries across the 19th and early 20th centuries, the comfortable world of classical physics, the familiar physics that we study in schools and colleges, began to collapse. Light was a wave, yes, but not a wave in air or water or any medium we could detect. It was a self-sustaining ripple in something else entirely. And then came the atom's own betrayal. We once imagined atoms as miniature solar systems, electrons orbiting a central nucleus like planets around a star. But this model crumbled too. Electrons don't orbit. They don't even have precise positions. They exist as probability clouds smeared across space like whispers. When we try to measure them, they jump. When we try to look at them, they change. The solidity vanished. And this is where the illusion breaks. Because at the heart of everything we know lies nothing. A chair is atoms. Atoms are mostly empty space. An atom is incredibly tiny, so small that it's difficult to grasp intuitively. To put the size on an atom into perspective, if you could blow up an atom to the size of a football stadium, the nucleus would be about the size of a marble sitting at the center of the field. The electrons would be tiny specks somewhere in the spectator stance. Even the nucleus, the tiny dot at the center of the atom, is not truly solid. It's a seething swarm of potential and kinetic energy, quarks and gluons held together by forces we barely comprehend. And the deeper we look, the less we find. Reality dissolves into energy, probability, and uncertainty. So what then is the world actually made of? Modern physics offers a stunning, almost heretical answer. The world is not made of particles. It is made of fields. Invisible, omnipresent, vibrating fields. Not just one or two, but a separate field for every known particle. An electron field, a photon field, a quark field. These aren't things you find inside space. They are space. Or rather, they define how space behaves. And particles, they're not little dots moving through these fields. They are the fields. Specifically, they are quantized ripples, excitations, tiny bursts of energy that emerge when a field is disturbed. In this view, an electron is not a speck flying through the void. It's a blip, a vibration, a wrinkle in an invisible fabric that extends across the universe. This idea is so radical, so unintuitive, that it still hasn't sunk into popular understanding. And yet it forms the bedrock of the most successful theory in physics, quantum field theory. This concludes part 1 of the series. In part 2, we'll explain why quantum field theory, or QFT, doesn't just describe how particles behave. It predicts them. Every particle interaction, every force, every shred of matter in the universe is governed by how these fields overlap, interfere, and ripple across the cosmic stage. So please join us in part 2. Before we say goodbye for this session, we would like to share a message from our sponsors, the spectacular Nankana Nature Resort, located near the historic city of Nankana Sahib, in Punjab, Pakistan, just 60 kilometers from Lahore on the M3 Lahore, Multan, and Karachi motorway. So please take a listen. Welcome to our cosmic curiosity garden at Nankana Resort. Step into a world where wonder meets wisdom, where the grand tapestry of creation unfolds before your eyes in breathtaking displays that chronicle our extraordinary journey from the Big Bang to this very moment. The Cosmic Curiosity Garden isn't just a destination. It's an awakening to the profound mysteries that connect us all. Here, learners of every age rediscover that spark of curiosity that burns within us from childhood, exploring how Allah's magnificent order brought forth galaxies, stars, and planets through the dance of fundamental forces, the formation of matter from quarks to molecules, and the birth of our precious Earth. Whether you're a student seeking inspiration, a teacher igniting young minds, or a family wanting to share the awe of discovery, this garden offers a transformative journey through 13.8 billion years of cosmic evolution. As you walk among displays revealing the secrets of black holes, the expansion of the universe, and the delicate balance that makes life possible on our planet Earth, which appears as just a pale blue from space telescopes located millions of miles away, you'll understand why this knowledge isn't just science. It's the foundation for raising tomorrow's leaders with hearts full of wonder, minds attuned to the sacred nature of existence, and spirits committed to protecting the only home we, all of humanity and other living beings have. Come, let your curiosity bloom in this garden where the universe itself tells its story. Just one visit will open your eyes to the mysteries of our marvelous universe. We have engaging activities to offer schools, colleges, teachers, and families. These include immersive experiences such as planetarium storytelling sessions, where we have age-appropriate narrations of cosmic stories, from how stars are born for younger kids to the search for exoplanets for older ones. Interactive discovery stations such as the Solar System Scavenger Hunt. Here kids and family members race to find planet stations scattered across the garden, collecting facts and stamps at each location that complete our solar system, with distances, sizes, and other facts. We have hands-on atom-building workshops where students use large, colorful models to construct atoms and molecules by combining protons, neutrons, and electrons pieces, learning how everything around them is built from these basic components. There are creative expression activities such as designing your own planet. Children create habitable worlds, considering factors like distance from stars, atmosphere, and what life might look like there. And for groups and families, we have special events which include star-gazing nights, with telescopes guided by local astronomers, connecting garden learning to real sky observation. Cosmic Career Days, from experts in cosmology and astrophysics who share their journeys and inspire future scientists. Universe Birthday Parties. Yes, indeed. You can have your birthday celebrations with a real Big Bang, with special demonstrations, cosmic cake, and reflection on our shared cosmic heritage. These activities blend education with excitement, ensuring that the wonder of cosmic discovery becomes a memorable family experience that kids will treasure and teachers can build upon back in their classrooms. Please visit the links below for further details.